All right. Okay, I'm broadcasting. All right. So, how did you feel about this chapter?
It's pretty straightforward. I couldn't, my computer for some reason keeps crashing when I try and pull up the preparation assignment. Or it
Okay.
doesn't crash, but it won't pull it up.
It won't download it? Okay.
Processing. So
Hmm.
I haven't been able to see what the practice assignment is or anything. Um,
Okay.
I can't pull up the answer key or the
It's stuff like, what's the definition of p-value, and then it's a lot of, state the null and alternative hypothesis, but you do it in the little a alpha equals
oh,
mu
okay,
equals the mean, and then down below for the alternative, it's alpha equals mu, and then it's either an equal sign with a line through it for different, or it's a less than or a more than sign. So
okay,
just depending on the question. So it's a
right,
lot of those, and then figuring out z-scores, and then figuring out the p number, yeah, a p-value. And then when you figure out those, figuring out sometimes having to figure out if it's the level of significance. Is that what it is?
yeah, the
Is
alpha.
that what it's called? That, yeah, the level of significance, if it's like less than or more than, and then whether we're going to reject um, or accept the null hypothesis, or fail to reject, reject or fail to reject. So never
That's right.
accept.
Never true. Yep, it's never true. Okay, well then do you want to go ahead and just start with the quiz
The
then?
quiz. Yeah,
Yeah.
let's get to it. I've got a babysitting kid coming in about 15 minutes, so I
Oh,
might have to
okay. That's
step away
right.
from the computer to get my door and say hi. So,
Oh, it looks like
okay.
it's pretty short. There's only 20 questions.
Oh, okay. Let me get
The
into it
first
here.
two, are whether or not we're completed the assignments. So,
Oh, okay. Yeah. Let's see. Group. We want group meeting.
okay. And I was able to, I did take a bunch of the extra links for the assignments. I
Okay.
there are four different ones, and I've
Mm-hmm.
watched almost all of them. There's one or two, and the last two I haven't been able to do, but
Okay.
that I took a bunch of notes from that, so hopefully that will help too.
Oh, okay. Great. Yeah.
Uh,
Okay. A hypothesis test consists of two hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? That would be the null hypothesis.
yep, because there's never a true, and it's
Mm-hmm.
okay. Which hypothesis involves equality? That would be
The alternative hypothesis.
yeah, yep.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true? The null.
No, yeah.
Okay, suppose the null hypothesis is um, 10. Use this information to answer questions 6 through 8. Which
Or
of the following represents the alternative hypothesis for a two-tailed test? So it would
so
be the equal
not
one with the line through it.
not equal. That's what I got.
Yeah, the not equal. Which of the following represents the alternative hypothesis for a left-tailed? So that would be,
Less
I
than
think
10.
that's greater than, yeah.
That would be so the mouth is open to the 10, right?
No, that would be less than. Let me see. Let's go. Let's double
Left,
check my work.
the left the left tail is on the you want the left side, so that's less than 10.
Oh, is that what it is? Let me see.
Okay,
Sometimes I get these confused, so let me see, where is it?
let me double check the notes too, but I'm pretty sure that's right. Okay.
Okay, so but it looks like, yeah, it's less than. So it's left-tailed if it's less than.
Yeah.
I've got it right here. Okay. So it should be pointing, like eating the 10.
Yeah.
Okay. So the second,
I
I think it's my.
still refers to it like that, the crocodile or whatever.
Yeah, exactly. I'm like, that's how I learned it a long time ago. So, okay, so less than 10. Okay, which of the following represents the alternative hypothesis for a right-tailed test? So that would be greater than.
Yeah, so the mouth is to the U.
Yes. Okay.
Whatever.
Okay, the outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information for questions 9 through 10. Which value would result in failing to reject the null hypothesis? Okay, this is where I get really confused.
The null hypothesis would be in favor of the null. So that means the p-value would have to be, this is where I have to look at my notes because I get it confused with the whole failing to reject or rejecting.
Yes, this is where I get really confused. Okay, so the outcome of a hypothesis test is determined by comparing the p-value to the level of significance. Okay, which relationship would result in failing to reject the null hypothesis? The p-value, failing to reject. Okay, I've got my little chart here. If it's a large p-value, you fail to reject. So the p-value would be greater than the mean. You would fail to reject.
Okay, hold on.
Greater than, but what is it? Z-score. Oh, okay. No, it's not Z-score. It's greater than the alpha. Let's see.
Okay, so if the p-value is smaller than the A, this would be considered, that would mean that the null hypothesis would be rejected. So then the opposite would be true, like what you were just saying. If the p-value is greater than the A, then you would just keep the null hypothesis, right?
Yeah.
So if the p-value is greater than A,
so it should be pointing towards A.
To reject, right?
I think so.
Rejecting means that, okay, if the p-value is smaller, then you reject.
If the p is low, reject the null.
Right. If the p-value is bigger, then the null, it hasn't been proven yet. So you would fail to reject the null. So it's got to be the p-value is greater than the
alpha.
Yeah, alpha.
Okay, so it should be pointing towards the A.
Pointing towards the p-value, because it has to be, the p-value has to be bigger than the A. Because if the p-value is smaller than the A, so that the mouth is towards the A, then you fail to reject. If the p-value is greater than the A, oh wait, now I just messed that up. I said it the opposite. Okay, so if the p-value is smaller, I'm just reading the straight out of the text. So if the p-value is smaller than A, then
you reject.
It's rare, right? It's rare, so the so you reject the null. So if the p-value is greater than, the opposite would be true, which would mean that you
fail to reject.
So yeah, it's got to be p-value is greater than A, or the mouth is going towards the p-value. It has nothing to do with the you can eliminate those.
Right, and the point is towards the A. Okay. So mouth is open towards the p-value, point is towards the A. Okay.
Yeah.
All
And
right.
it's opposite than for the one under them.
Okay. Which relationship would result in rejecting the hypothesis, so it would be going the other direction?
The point would be towards the p-value because the p-value would be smaller.
Mm-hmm. Oh, not Z. It's got wrong. Okay, so p-value is less than A.
Yeah.
Greater than A, less than A. Okay. Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 to 12.
Okay, so if the claim, they're concerned that the true mean is actually higher than this. So this is like the ferry example, right? Both. So the hypothesis would be that the
To the following would be the appropriate hypothesis, alternative hypothesis. So it would be that the
is greater than
higher, yeah, that it's greater than the 1,500. So the average claim amount is greater than 1,500. Yes.
No, but would this be one of those things? Remember how they were saying that it's better. Okay, maybe I'm confusing something. But I remember reading somewhere where they were saying you don't want to actually say it's greater than or less to necessarily unless you have the amount. Otherwise, you just say that it's not equal to. But maybe that was in one of the first pages. Or one of the very first.
Yeah, because
Oh. Or maybe it was down further. Hold on.
Well, not equal would be that equal sign with the line through it, but this is actually saying that they are wanting to know if it's higher than that, so it'd be greater.
Greater, yeah. Okay. Which of the following would be the appropriate null hypothesis? So the null hypothesis
is the status quo, the average claim amount, so it'd be equal, yeah. The average claim amount is equal to 1,500. Yeah, that's the null.
Right. Oh.
Okay, so the insurance company selects 40 claims and calculates a sample mean of 1,650. Use this information for questions 13 through 15. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yeah, because there's more than 30.
Yes, yeah. What theorem of law justifies your answer? The central limit theorem, right?
Yeah, let me double check that.
Well, it would be either the law of large numbers or the central limit, but the central limit's the one that says if your sample is high enough, and it's the one that was referred to in this lesson.
So that would actually be the law of large numbers then.
Well, they don't talk about the law of large numbers in this lesson. They say, let me see, where is it in the textbook? Okay, I'm going to go back.
What we're saying is we're saying that it's true because n is higher than 40. Oh, because we're talking about.
Yeah, it's the sample that is large, and that's part of the central limit theorem. But let me see if I can find it in the textbook.
So, if the law of large numbers means that the sample will get closer to the population mean, and the standard deviation will go down.
Yeah, this isn't about the law of large numbers.
It's the central because it's just talking about.
Yeah. Just normal, and you have to either have a normal population or a large sample. So, okay. I can't find it. Let's see. Maybe it's in the significance area. Requirements? Requirements. Okay. In reading for distribution of sample means and the central limit theorem, lesson 6, we learned that X will follow normal distribution if the data are drawn from a normal distribution or if the sample size is large. So yes.
Yeah, central limit. Okay.
Okay. Which of the following is the test statistic as defined in this lesson?
That would be N.
What? No, the test statistic is the Z number. The Z.
Why would it be Z?
Because it's the Z score. The test statistic is the Z score.
Okay, where is that at?
Okay, I'll find it here in the textbook. I've been going through the homework and there's a lot of those too. Just heads up. But okay, test statistic is 4.2 in the textbook, and yeah, it's the Z score. It's figuring out the Z score. Assuming that the null hypothesis is true, we assume that the true mean body temperature of healthy adults is actually blah, 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 blah. A histogram of the body temperature data shows a nice bell-shaped distribution. Also, the sample mean, blah, 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 appears to be reasonably close to the assumed population mean. However, it is important to remember that the standard deviation, X, is, what is that? The O symbol over the square root of n, which is 0.055. We need to determine how far x is from mu. Since we know the standard deviation in this case, we can use the z-score to determine if x is far from the assumed value. This is called the test statistic. So yeah, it's the z.
Let's determine the x, okay. So why wouldn't it be the x? The static should be the x, though, not the z. Because so it's saying that because we know the standard deviation, we can use the z-score to determine the x bar.
Is far from the assumed value.
This is called this. So which one is it? Is it really the x bar? I think the x bar is the static or the statistic then. Let me see if there's
yeah, you might be right. I don't know.
Because the z-score is still, the z-score is just the value or the distance from the mean, right?
Yeah.
So, but the x is actually the sample or the sample population, if you will, versus the total parent population.
Okay.
Seems like the static would be the x bar because the static. So.
Statistic, yeah. It's.
Sorry, calling it static.
It's okay. It's all right.
The previous lessons, there were always the statistic is always the value of the sample or the x bar.
Okay.
I don't know, and I don't think that would change from last. You know.
Okay, so it's not the z-score; it's the
x bar.
Okay.
We can just find the x bar or the statistic using the z-score.
We use it. And I think that's what confused me because they're like, this is how you find it. So I was thinking of more the steps to find it than the actual. Okay, that makes sense.
Okay. So the historical mean of sales receipts at a grocery store is $150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. So then we've got the null on the top and then the alternative null on the bottom.
Which is looks like it's less than 150.
Yeah.
Mm-hmm.
She would level of significance A at 0.05. She then takes a sample random a simple random sample of 36 sales from her store and computes that the X bar is 144. So this is easy. So we just take 144 minus 150 divided by 40, right? And we don't have a number.
Yeah, she takes a random sample of 36 sales receipts.
Divided by. Okay, let me work this out and then we'll compare.
Yeah, I'm going to work mine out too. Let's see. Where is the standard deviation? Oh, it's 40. So I get a z-score of, well, you figure it out and then.
Okay, so I got negative 0.900.
That sounds right because it's like negative 0.89999 or something like that. So it's a negative. Oops. Negative 0.90. Where is it? .900. Is that what you get? Negative 0.900. Okay. What is the p-value associated with the z-score from the previous question? So we need to go to our normal probability app and enter in 0.900. And are we trying to find, which way was it?
Hold on. It was greater than, right? So it'll be on the right side. Okay, hold on.
So she's trying to find, she's finding the average, she thinks the average has decreased, so she feels like it's less than.
Oh, sorry.
It's okay. So we're going below the z-score. So I've got, okay, hold on just a second. My babysitting kid is here. Just 1 second, okay? Okay, I'm doing my meeting stuff. Okay. Okay, I'm back. Sorry. All right. So yeah, so I come up with a p-value of 0.184.
Yeah, that's what I got.
Okay. Come on. There we go. Okay, what inference would you make about the null hypothesis for this problem? Okay, so we're trying to go under 0.05. The p-score is above that number.
It's a pretty big number, so I would say fail to reject.
Fail to reject.
Because you only reject the null if the p-value is smaller than. That's
right.
Alpha. So it's bigger than, right?
Yes.
So it is fail to reject.
I hope that's right. I always like go back and they're like, no, it's supposed to be the other one, and I'm like, oh. So I'm just gonna look over my notes really quick just to make sure because I keep getting those confused. If the p is low, reject the null. If the p is not low, it's higher, then you fail to reject the null. Okay, I think we're okay.
Yeah, we got it.
Okay, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Oh, that
Oh,
just.
I've got my chart here.
Yeah.
So we're rejecting the null hypothesis when it's true, right? That's a type 1 error.
Okay, hold on.
Yeah, go ahead and look.
I just have to process this.
Yeah, it's okay. There's a little chart in the textbook that helped me.
Yes, that's what I'm thinking that. But okay, so we are failing to reject the null. Which of the following involves the null hypothesis when the null hypothesis is true? So, involved rejecting the null hypothesis. So,
when it's true.
The null.
So the hypothesis is true. It's in that column. And we're rejecting.
So that's the first one.
Yeah, it's the type 1 error.
Okay. I was looking at my little notes, but where is that little graph in the
yeah, let me find it here. Where is that?
I know I've seen it somewhere.
Yeah.
Oh, here it is. Okay, so if we are rejecting...
Where did you find it?
It's in section 4.5.
4.5. Type 1 and type 2 errors. Yes, right there.
Hold on.
So we're rejecting it and it's true. And so that's a type 1 error.
Yeah, okay.
If we were failing to reject and it was actually false, so we're saying that the null hypothesis is true by failing to reject it, and it's actually false, that's a type 2.
Which one involves rejecting the null? So
like they gave this scenario, like the BYU Idaho Honor Code specifically prohibits wearing flip-flops on campus.
Oh, that's right.
A student is seen on campus wearing shoes that look somewhat like flip-flops, considering the following null and alternative hypothesis. So if you're saying the shoes of this type are technically flip-flops and the alternative hypothesis is the shoes of this type are not technically flip-flops. So to get a type 1 error, you would say you decided that they were not flip-flops when in reality they were. So so the hypothesis is true, but you're saying it's not true and you're failing to reject it. Yeah. Or yeah, rejecting it when it's actually true.
Right.
I don't know if that helps at all. I get confused. So.
You too.
Okay.
Okay, so a researcher decided that instead of using a level of significance of 0.05, he will use 0.01, which of the following will be true. Oh, they covered, this was in the lesson too. The probability of type 1 error will increase. The experiment will be more scientifically valid. No, it's definitely not that one. The probability that the null hypothesis is true will decrease. The probability of, okay, it's going to do with the 2 errors.
Okay.
So, but let's find it in the book where it talked about the differences between the 0.1.
Oh yeah, what the differences? Yeah, it's in there. Let's see. Probably in that same section we were just in, but let's see.
It is. It's 4.5. We choose alpha to be some small number, so the probability of committing type error is low. The most common value is 0.05. So when the null hypothesis is true, there's only 1 in 20 chance that it will be rejected at that level. Another common choice is 0.01. Okay, just under the graph or the table, it says we do not want to commit type 1 errors. So
why choose a small value for alpha? If we choose A to be small, that we rarely commit a type 1 error, what would happen to the probability of committing a type 2 error? Think about it. if the alpha value, the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be large.
So
conversely, if A is allowed to be very large, like the 0.05, then the probability of committing a type 2 error will be very small. Level of significance of A seems to strike a good balance between the probabilities of committing a type 1 versus a type 2 error. And they said, however, let's see. So what's the question again? It's saying researchers decided instead of using the 0.05, he will use a 0.01. So that would decrease. It would increase the type 2 error. Is that right?
Okay, so where are you at again? Seems you're committee type 1 versus type 2.
Okay, so it's 4.5 below the chart. If the A value, the probability of committing a type 1 error is very small, then the probability of committing a type 2 error will be large. So if it's 0.01, if it's 0.01, then it will be it will make the probability of committing a type 2 error larger. Is that right?
Because 0.01 is bigger.
Yes.
Than 0.05.
Well, it's smaller. Yeah. But it will increase the type 2. Whereas if we did the 0.05, that would increase the type 1 error. I think that's at least what I'm understanding from it.
Okay, so but 0.01 is actually bigger than 0.05. Closer to 0 or 1.
Oh, is it? Okay, let me think.
Right? Isn't that right? Don't count. So, like,
I thought it's a smaller number because the 0.05 is a bigger number than 0.01 is.
Well, 0.05. I'm sorry. I was thinking of negatives.
That's okay.
Positives, yes. 0.01 is smaller than 0.05. Okay. So it's even smaller. So that's good then, because it means that
it will decrease the type 1 error, but it will increase the type 2 error. Okay. And when it's larger, like it's the 0.05, it will decrease type 2, but it will increase type 1.
So the answer then should be?
The probability of type 2 error will increase.
Okay. Okay, so if alpha is 0.05, what's the probability of committing a type 2 error? Oh, they just gave that to us. It's 1 in 20, right?
Yes. How did you? Oh, but you have to. I don't know. How do you calculate that?
Well, it would just be 1 divided by 20.
Oh, okay.
And so it's right above the table. When they're talking about the third paragraph in 2.5, because the most common value for A is for alpha is 0.05. This is equal to 1 divided by 20. So when the null hypothesis is true, there is 1 in 20 chance that it'll be rejected at whatever level.
But this is saying compute the probability of committing a type 1 error. So when it's because it's a higher number, it increases the type 1 error.
Right. 0.5 is low. Error, type 1 error is really low.
Okay. Yeah, type 1 is 1 out of 100. So is the answer just 0.05?
That's what I'm thinking. Compute the probability. Let's see anything about that in
the textbook. It says exactly what you said. The most common value says we choose A to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05. This is equal to 1 out of 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Other common choices for alpha include 0.01 and alpha equals 0.01. 0.1 and 0.01. If committing a type 1 error is undesirable, we can't let alpha equal 0. This would make it impossible to commit a type 1 error. Actually, this would also make it impossible to reject any null hypothesis. If A equals 0, no matter what test we do, not matter what the data shows, we always fail to reject the null hypothesis. This would be pointless. So the smaller the number, the less possibility of committing a type 1 error, so, and that's what it's asking for. So is it the 0.01?
Well, it can't be 0.01 because...
Well, that says it's other common choices for alpha include A.1 and A equals 0.01. The 0.01 is 1 out of 100, so that really decreases the chances for committing a type 1 error. But they're saying in the question something different. If A equals 0.05, compute the probability. Okay, so no, because this tells us right here that that's the number that they're using. So
it's got to be that because, okay, so rereading the description from the very first one.
Yeah.
The most common value
is the 0.05,
which is equal to the probability of 1 in 20.
So do we put 1 /20 or do we put 0.05?
1 divided by 20, the probability is 0.05.
Mm-hmm.
You know what I mean?
Yeah.
Remember, so this is what I'm thinking about. So I'm remembering the dice, right?
Mm-hmm.
So to figure out the probability of rolling any number on a dice, it's 1 in 6, right?
Mm-hmm. I'm just trying to figure out how to enter this. So do we do the 1 /20 or do we do 0.05?
0.05.
Okay. I'm good with that.
All right. I think that's correct. And let me just double check it with here. Okay.
I'm just going back over our answers.
Okay. Okay. Yeah, it's got to be that because a 1 in 20 is a 5% chance,
Mm-hmm.
and 5%.
Is 0.05. Yeah, it's just weird because it's just right there in the question. I'm like,
I know, because you think that it should be harder than that.
yeah.
Okay, I'm pretty confident we got them all right. Looking at looking at everything.
Yeah, I'm just looking over everything, making sure I've entered it in the right spots. Yes. Central limit theorem. Okay. And you got for 16 negative 0.900 and 17.184.
For 16, negative 0.900, yeah. 17.184.
Mm-hmm. And so failed to reject the null hypothesis.
Type 1, type 2 error will increase. Yeah, we did it.
Okay. Okay.
I'm submitting.
All right, me too.
My heart always skips when I do this. Ah, we missed one.
Oh, yes, we did. Okay.
Oh, no, we missed 2. Crud. We did miss that.
Oh. The hypothesis involves equality. It would be, we put the alternative, but maybe it's the true hypothesis.
No, it's the null. How did we miss that? Because the null. There is no true hypothesis, remember?
Yeah, there's not. Okay. So it was the null. I don't know why we just went opposite.
Well, no, that's not right, because which hypothesis involves the equality?
Yeah, I thought that was the alternative.
The null hypothesis is either not...
Is always equal, or?
It's either not equal, greater than, so equal has to be the null.
And so I think that was the z-score for 15, because that was the other one that we got wrong. Okay, that's a bummer.
I want to ask him about that too, because the z-score is just what you use to find the x value, which they said.
Mm-hmm. Okay. All right.
On the upside, we still got a 90.
I know. 91. It just seems to be my week, so. What's that?
That number 4, we just didn't think through it enough.
Yeah. Yeah.
Got it.
I think we were just skimming over those, and I don't know, sometimes, yeah. I guess I should have paid more attention to that one. I just was like, oh yeah, it's the other one.
Well, I think I was reading. I wasn't necessarily reading the equality as exactly equal to. I was just reading it as which one involved equality.
Yes.
Or not.
That's what I was thinking. I was thinking the less than, the greater than, because that's the one that you write out that way.
Right.
So.
But I didn't realize it was specifically referencing only the equal to. Equality in general. You know what
I mean? I think that's what I was thinking the same as you. I didn't catch that.
Oh well.
Okay. I'm going to stop broadcasting.